Hello friends, welcome to PG Department of LJ University. This is a lecture series of subject Applied Mathematics for the first semester student. Here I, Darwin Patel, presenting a concept of Bayes theorem or posterior probability on this unit number 5, probability part 1. Already we studied about the probability and conditional probability in the previous two lectures. Now we will discuss about the posterior probability on this video. Here posterior probability is nothing but when the occurred event have a partitions and our favorable events is coming from which partition, that is called the posterior probability. So here it is also known as the concept of Bayes theorem. So we will understand with the one simple example. If two boxes have some balls of red color and black color, in the box 1 we have a 4 red ball and 3 black balls, total 7 balls, and in the second box we have a 3 red and 6 black balls. So total number of balls in second box is 9. Now if we pick up the one ball from that boxes and we don't know from which box we are picked up, but if it is a red ball, then what is the probability of it is from one box or two box, and that type of events or probability is known as the posterior probability, or it is calculated by Bayes theorem. So here let E1, E2, En are disjoint events of sample space S, and the union of that events is S, as well as they are disjoints and each event is non-empty. So it is the probability of Ei is greater than 0. Ei and Ej are disjoint events for all I not equal to j, and third condition is E1 union E2 up to En all are is equal to S. So finally A be calculated by the total probability theorem. So A is any other event and it intersects maybe all partitions, and now probability of Ei slash A is actually our posterior probability. It is calculated like this: probability of Ei into probability of A slash Ai upon probability of A, and probability of A is also calculated by total probability theorem. So this concept is already we studied in the previous slide, total probability theorem. So it is a total probability theorem I am writing here. These are the disjoint events, and this events union is actually S. So probability of A3 slash A can be calculated by this formula, and in the denominator we are writing the probability of A using the total probability theorem if we don't know the probability of A directly. So that is the concept of Bayes theorem, and here we are writing the probability of E3 slash A. That is our posterior probability from the partition of S. And now we will see some examples. Bag 1 contains the 3 red and 4 black balls, and another bag 2 contains the 5 red and 6 black balls. One ball drawn randomly from the bags, and it is red ball. We noted it, and what is the probability? It's coming from bag number 2. So here bag 1 contains the 3 red and 4 black ball, total 7 balls. Bag 2 contains 5 red and 6 black balls. So finally it contains the 11 balls, and now we want to find the probability of selected red ball coming from which bag. Here we want to find the probability of selected red ball coming from bag number 2. So that is the posterior probability. E1 is bag 1 is selected, event and E2 is back to is selected event. So these are our partition of our random experiment, and probability of E1 and E2 are same, which is 1 by 2. We know it easily, but A is event, selected ball is red. It may be coming from bag number 1 or 2, but here we want to find the probability of A slash E1. That means the probability of ball selected from bag number 1, and probability A slash E2 is probability of red ball which is selected from bag number 2. So each concept is ready now, and now this is our probabilities of A slash E1 and A slash E2. So we want to find the selected red ball was coming from bag number 2. That is our probability of E2 slash A. So that is our posterior probability, and we will use the Bayes theorem for that particular part, and this is our formula according to the Bayes theorem. Probability of E2 slash A equal to probability of E2 into probability of A slash E2 upon probability of A, and here we are applying the total probability theorem. So that is our concept of probability of E2 slash A, and now we have all the events probabilities ready. So we are applying the 1 by 2 in place of probability of E2. Probability of A slash E2 is 5 by 11. Already we calculated it, and the probability of A is in the denominator, and it is calculated by total probability theorem. So here we are applying the total probability theorem, and now after simplifying we have in the numerator 5 by 22, and in the denominator we have actually 3 by 14 plus 5 by 22. So after simplifying properly we get the final answer is 35 by 68. So that is our concept of total probability theorem. E2 probability of A slash E2 is 5 by 11. Already we calculated it, and the probability of A is in the denominator, and it is calculated by total probability theorem. So here we are applying the total probability theorem, and now after simplifying we have in the numerator 5 by 22, and in the denominator we have actually 3 by 14 plus 5 by 22. So after simplifying properly we get the final answer is 35 by 68. So that is our concept of total probability theorem. Now we will see the another example. Two persons hit the target through bullets. Here A throws the 9 bullets and B throws the 10 bullets, and out of 10 bullets A can hits 8 times target, and out of 10 bullets B can target the 7 bullets, hit the properly target 7 times. So A bullet is found that the target is hit. What is the probability that it is thrown by B? That means if we know the target is hit, and what is the probability it's that particular bullet is thrown by person B. So here H1 is bullet thrown by A person, H2 is event bullet thrown by B person. We assume it, and now K is event. That means the bullet is hit the target, and in this case the total number of thrown is 19, because A target throws the 9 times and B throws 10 times. So finally probability of H1 is 9 by 19 and H2 is 10 by 19. Now the probability of k/h1 is probability of hit the target by person A, and here A used the 10 bullets for throw, and out of that 8 are hit properly, so it is probability 8 by 10. And similarly k/h2 is hit the target by person B, and here B used the 10 bullets, and out of that 7 are hit properly, so that is our probability. And now here we want to find the probability of hit the target by person B. So here we now want to find the probability of h2/k, and its formula according to Bayes' theorem is this. And now we will calculate each term because all the probabilities are ready. So here after calculating we get the answer 35 by 71. So finally here we calculated the concept of posterior probability using the Bayes' theorem, and in the next time we will discuss about the random variables and marginal probability. Thank you very much.